Welcome to Python closures. Have you ever wondered how some functions seem to remember things even after they've finished running? That's exactly what closures do. By the end of this video, you'll know what they are, how they work, and when to actually use them in real projects. Don't worry if it sounds confusing right now. We'll take it step by step. Let's start with a real-world analogy. Think of a backpack. When you leave school, you don't remember everything that happened in the classroom. But whatever you packed into your backpack comes with you. A closure is like that backpack. It's a function that carries data with it from the place where it was created, even after that place no longer exists. More formally, a closure is an inner function that remembers variables from its outer function, even after the outer function has finished running. For a closure to exist, three things must happen. First, a function must be defined inside another function. Second, the inner function must use a variable from the outer function. Third, the outer function must return the inner function. Watch the code on the left as we define our outer function with an inner function inside it. Notice how inner function uses the greeting and name variables from the outer scope. When we call outer function with Sarah as the argument, it returns the inner function. Now, here's the magic. Even though outer function has finished running, when we call, say, hi, it still remembers greeting and name. That's a closure. Let's build a simple example to make this concrete. We have a makeGreeter function that takes a name as a parameter. Inside it, we define a greet function that prints a personalized greeting using that name. The makeGreeter function returns the greet function. When we call makeGreeter with Alex, it creates and returns a closure, a greet function that has Alex packed into its backpack. Even though makeGreeter has finished, when we call, say, hello, it still knows to greet Alex. Watch how the variable state panel shows name being captured and remembered by the closure. Now, let's see a more practical example. Say you're building a tip calculator for a restaurant app. Different restaurants have different tip percentages. Instead of writing separate functions for each percentage, we can use closures. Our tip calculator function takes a percentage and returns a calculate function that remembers that percentage. When we create 10% by calling tip calculator with 10, we get a closure that always calculates 10% tips. 15 and 20 are similar closures, each remembering their own percentage. Watch the memory model on the right. Each closure has its own percentage value stored in memory. When we call 10% with a $50 bill, it returns 5. 15% gives us 7.5, and 20% gives us 10. Each closure independently remembers its percentage. So far, our closures have just read variables. But what if we want to change them? By default, an inner function can read outer variables but not reassign them. To change that, we use the nonlocal keyword. Here's a score tracker for a quiz game. The createScoreTracker function initializes score to 0. The addPoints function uses nonlocal score to tell Python, I want to update the outer score, not create a new local one. When we call playerScore with 10 points, the score becomes 10. Call it again with 25, and score becomes 35. One more call with 5 points, and we're at 40. The score variable lives inside createScoreTracker, but addPoints can update it every time, and nobody outside can accidentally mess with score. It's safely hidden inside the closure. If you find yourself writing nearly identical functions that differ by just one value, a closure factory can replace all of them cleanly. Here's our unit Numencharacter factory. It takes a conversion factor and a unit name, and returns a convert function that remembers both. When we create Carol Numu to miles with the factor 0.621371, we get a closure that always converts kilometers to miles. Similarly, Carol Numu to pounds is a closure that converts kilograms to pounds. Each closure remembers its own factor and unit. When we call Caronu to miles with 10 kilometers, it returns 6.21371 miles. When we call Caronumu to pounds with 70 kilograms, it returns 154.3234 pounds. One factory function creates many specialized converters, each with its own configuration packed in. Closures give you private state, data that only the inner function can touch. Here's a download progress tracker. The create progress tracker function takes the total number of files and initializes completed to 0. The file downloaded function uses nonlocal completed to increment the count and calculate the percentage. When we create track for 4 files, we get a closure that maintains its own completed counter. Each time we call track with a file name, it increments completed and prints the progress. After video.mp4, we're at 25%. After audio.mp3, 50%. After image.png, 75%. And after readme.txt, we're at 100% complete. The completed variable is completely hidden. Only the file downloaded closure can access it. This is a powerful way to encapsulate state without using classes. In web apps, games, or GUI programs, you often need to pass a function to be called later. Closures let those callbacks carry the data they need. Here's a notification system. The createNotifier function takes a platform name and returns a notify function that remembers that platform. When we create email modified, SMS modified, and push modified, each one is a closure that remembers its platform. Later, when we call email modified with order shipped, it prints email in brackets, because that's what it remembered. Same for SMS and push. Each notifier closure carries its platform with it, perfect for passing around as callbacks that need to know where to send notifications. This one trips up a lot of beginners, so pay close attention. Look at the code on the left. We're creating 3 button click handlers in a loop. You might expect button 0 to print button 1 click, button 1 to print button 2 clicked, and button 2 to print button 3 clicked. But the actual output is button 3 clicked 3 times. Why? Because all 3 functions share the same num variable. They don't capture the value of num at the time they're created. They capture a reference to num itself. By the time you call them, the loop is finished and num is 3. The fix is to use a default argument, def on click with n equals num. Default arguments are evaluated at function definition time, so each closure gets its own n with the current value of num frozen in. Now each button prints the correct number. A closure can often do what a simple class does. Here's the same counter written both ways. On the left, using a closure, makeCounter returns a counter function that maintains its own count variable using nonlocal. On the right, using a class, counter has an init method that sets count and a call method that increments and returns it. Both produce the same output, 1, then 2. So which should you use? Use a closure when you only need 1 or 2 operations, when you want something quick and lightweight, or when the logic is simple. Use a class when you have many methods or operations, when you need inheritance or more structure, or when the logic is complex or shared. Neither is wrong. It depends on the situation. The comparison table shows the trade-offs. Closures win on simplicity. Classes win on structure and extensibility. Let's recap what we learned. A closure is an inner function that remembers variables from its outer function. 3 conditions must be met. A nested function that uses an outer variable, and the outer function returns the inner function. Use the nonlocal keyword when you need to update a captured variable, not just read it. Closures are great for function factories, hidden state, and callbacks. Watch out for the loop trap. Closures capture references, not values, unless you use default arguments to freeze the value. And remember, closures are a lightweight alternative to simple classes. Now that you understand closures, you're ready to explore decorators, which are basically closures with superpowers. We'll cover those in the next video. You've mastered Python closures. From understanding what they are, to the 3 rules, to practical examples like tip calculators, score trackers, and notification systems. You even learned about the loop trap and when to use closures versus classes. If this helped you, give it a thumbs up and subscribe so you don't miss the next video on decorators. Drop any questions in the comments below. I read every single one. See you in the next one.